Good morning, students. Chapter 7, Alternating Current. Yes, exercise questions. See, exercise 7.20. LCR series AC circuit having inductance 0.12 Henry, C 480 nanofarad, R is equal to 23 ohm, V RMS is equal to 230 volt, and variable frequency. First question: what is frequency when current is maximum? Amplitude of current is maximum, and also find that maximum current. Very simple question. IRMS means maximum current. Amplitude of current becomes maximum when amplitude of current becomes maximum when it is operating at resonant frequency. So yes, we have to find resonant frequency. So yes, resonant frequency omega 0, it is 1 upon under root LC. It is angular frequency, okay? Angular resonant frequency. Yes, I will here write what? Angular resonant frequency. If you want to write only frequency, then F 0 it is 1 upon 2 pi under root L. So yes, you have to find both. Okay, yes, you have to find both. Next question is, what is maximum amplitude? So yes, I max. It is I maximum or I RMS maximum. I RMS maximum is equal to, it is V RMS, and we know that at resonance impedance is only R. Impedance is only R. So yes, you know that at resonance impedance is only R. Clear about this? And yes, from this value you can also find its maximum value, that is IM. The IM, it is root 2 IRMS maximum. Clear about this? So yes, simple questions. Omega 0 is equal to 1 upon under root LC. F 0 is equal to 1 upon 2 pi under root LC. IRMS maximum is equal to VRMS upon R. IM is equal to root 2 IRMS maximum equations. Second question, what is angular frequency when power is maximum? Again the same thing. Okay, power is maximum when current is maximum, and current is maximum at resonant frequency. Okay. The power is maximum when I is maximum, and I is maximum at resonant frequency. At resonant frequency. So yes, here you have to find omega, that is nothing but omega 0, it is 1 upon under root LC, or F0 is equal to 1 upon 2 pi under root LC. And yes, you have to find what is maximum power. So yes, maximum power, maximum average power, P is equal to, it is V RMS I RMS. Simple, it is V RMS I RMS. V RMS 230, I RMS we will get from this equation. Simple. Yes, yes, it is simple. Clear about this? Yes. Because at resonance, again at resonance, I will write here, okay, at resonance, cos del is equal to, it is, okay. Next question, you have to find frequencies when power in circuit is half power, which is at resonant frequency. So yes, you have to find omega 1 and omega 2, if you remember, omega 1 and omega 2. What is equation of omega 1 and omega 2? Omega 1 is equal to omega 0 minus delta omega. And omega 2 means it is, yes, omega 0 plus delta omega. Then how to find omega 1 and omega 2? First of all, you have to find delta omega. How to find delta omega? Delta omega is equal to, it is, yes, its equation is, it is R upon L. Delta omega is equal to R upon L. R is given. Yes, L is also given, so you have to find delta omega. Now, omega 1 is equal to omega 0 minus delta omega. Simple. And omega 2 is equal to omega 0 plus delta omega. Simple. Simple. Yes, yes, simple. Omega 0. Yes, you have omega 0. Delta omega you will find from this. Now, if I want to find F1, so simple. F1 is equal to, it is, F1 is equal to, it is omega 1 upon 2 pi, and F2 is equal to, it is omega 2 upon 2 pi. Simple. Yes, yes, it is simple. So yes, if you have to find angular frequencies or only frequencies, you can easily find with the help of this equation. Okay. Next question is, you have to find Q factor, and yes, you know what is equation of Q factor. The Q is equal to this 1 upon R under root L upon C. You are given each and every value R, L and C. So yes, you have to put value 1 upon R under root L upon C. Clear? So yes, one easy question which is again based on equations. Okay, now next question. See, exercise 7.21. Exercise 7.21. Again, LCR series AC circuit having inductance 3 Henry, capacitance 27 microfarad, resistance 7.4 ohm. You have to find what is resonant angular frequency. So resonant angular frequency omega 0 it is 1 upon under root LC, or F0 it is 1 upon 2 pi under root LC. First question over. Second question, what is Q factor? Q factor it is 1 upon R under root L upon C. Simple. Third one, okay, see, easy questions. This is easy questions. Sharpness of the resonance of the circuit by reducing its full width at half maximum by a factor 2. Means sharpness of resonance you have to increase by factor 2. So if sharpness we want to double by factor 2, we want to double. Sharpness means nothing but Q factor. So if you want to increase Q factor by double, okay, so see, Q factor, what is its equation? Q is equal to is 1 upon R under root L upon C. Now, in resonance, in tuning, L and C they are fixed for particular frequency, so we can change value of current. So Q and R, they are inversely proportional to each other. Okay, I want to increase sharpness by 2 times. I want to increase Q factor by 2 times. Then yes, I have to decrease this resistance because they are inversely proportional. So yes, here you have to make resistance half. You have to make this resistance half. Means if you are given resistance that is 7.4 ohm, you have to take its half. That is 3.7. That is 3.7. Clear about this? So yes, here you have to take resistance value. R is equal to it is 3.7. Okay. So yes, these are 2 questions which you have to calculate. Yes, which you have to calculate by yourself. Okay. Now next questions. Next question, exercise 7.23. You are given one step down transformer. Step down transformer having input voltage. Input voltage means voltage connected to primary and output means secondary. Again, input primary, output secondary. Yes. So input voltage is 2300 volt. Numbers of turns in primary coil NP it is 4000. You have to find numbers of turns in secondary coil if output is 230 volts. It is very good question, easy, and its equation is that is Vs upon Vp is equal to Ns upon Np. So make Ns a subject. So Ns is equal to it is Ns is equal to it is Vs Vp, and here it will be, and you are given Vs, yes, you are given Vs, you are given Vp, and you can easily calculate what is number of turns. And see, as it is step down transformer, Ns will be smaller than Np. Clear? Okay. Next question. Exercise 7.24. Hydroelectric power plant, you are given water pressure head at height 300 meter. Water flows at 100 meter cube per second. Turbine efficiency 60%. Electric power available at plant. Now, what is the meaning of this? See, if it is turbine, water pressure head at 300 meter means water is stored at 300 meter height. H is equal to 300 meter height. Okay, so now what is functioning of turbine? Turbine is used to rotate shaft of generator. Okay, so whenever this water flows in turbine, So in turbine there are vents like this. Okay, so whenever this water with very high kinetic energy, now from where it will get kinetic energy, this water is stored as height, so it has potential energy. When that water is flowing down, its potential energy converted in kinetic energy, and due to kinetic energy, these vanes, there is force acting on these vanes, and this turbine will rotate. This turbine will rotate, and this turbine is rotated. Its shaft is connected to generator. Its shaft is connected to generator, and yes, generator will produce electric power. It will produce electric power. Simple? Yes, it is simple. Okay, so yes, it is input. It is input, and here it is output, and here it is output. Why to write input and output? Because you are given efficiency. Efficiency eta is equal to 60% is equal to it is 0.6. Is equal to it is 0.6. Now what is equation of efficiency? What is equation of efficiency? See, efficiency is equal to, always remember equation of efficiency, it is output upon input. Okay, efficiency is equal to, efficiency is equal to output power upon input. Here how to write the definition of efficiency? Efficiency is equal to this water coming from height, it will rotate a turbine, it will rotate generator, and electricity is produced. So here output is electric power. Output is electric power. And what is input? What is input? It is nothing but this potential energy of height. It is nothing but potential energy of, is nothing but potential energy of water. Okay? Yes or no? Then how to write electric power? Yes, electric power. Electric power. Power means you have to take energy per unit time. You have to take time one. Okay, you have to take time. So electric power is equal to efficiency. Efficiency into potential energy of water. Clear? So yes, what is efficiency? Efficiency is, it is eta. Yes, it is eta. What is equation of potential energy? It is mgh. But you are not given m. You are not given mass. But you are given one. Water flows 100 meter cube per second. 100 meter cube per second. Meter cube, it is unit of volume. Meter cube is unit of volume. So yes, it is eta. I can write this time as rho v gh. Eta efficiency, yes, you know, rho, that is density of water, 1000 kg per meter cube. Volume per second, it is given 100 meter cube. G, that is G, and H, that is H. You are given height, that is 300 meter. So yes, with the help of this equation, you can easily find what is electric power. And yes, if you take per unit time, obviously it is time, it is power. Clear? So yes, these are some questions that you have to solve. And yes, one important message for you. Chapter 7, alternating current. It is easy. When you know each and every equation and how to calculate See, each and every equation involves basic calculation. It involves basic calculation. So yes, try these all questions by yourself. Try to calculate it. That's why I am giving these questions as homework to you. Okay, as homework to you, because it is scoring chapter. It is one scoring chapter. From this chapter there will be a question of 4 mark in board examination. Okay, it may be theory or sum, and if it is sum, then yes, it is scoring. Then yes, it is scoring. So yes, take care about this. Try to solve each and every question. If you have any doubt, 7574858001. For today, this is it.